Let's In this video I want to discuss motion of lift. This is a very common problem, but few students find difficulties in solving such problems. It's a very simple problem. This problem is suitable for the students of class 9, 10, 11, 12, and even for diploma engineering students and also BTech students. This is a very common problem, very simple problem. Say, for example, a man is standing inside a lift and the lift is going in the upward direction with an acceleration, constant acceleration. Okay, mind it, acceleration remains constant throughout the journey in the upward direction. So we know that when the acceleration is constant, we can easily apply Newton's second law of motion. According to that law, we know that force is equal to mass multiplied by acceleration. So we are not considering the motion of the lift. Instead we are considering the motion of the man only. So what we have to do first? First we have to draw the free body diagram of the man. What is free body diagram? Just you draw the man and remove the supports. Instead of showing the supports, you just show the force exerted by the lift. Show the force exerted by the lift on the man. Which force is this one? This is reaction force. Force of reaction offered by the floor of the lift on the man, on the body of the man. Okay. So since there is constant acceleration in the vertically upward direction, so there must be a net force acting in the vertically upward direction. Okay, there is a net force acting in the vertically upward direction. Say the net force is denoted by capital F. Okay, F for flower, capital F. So that resultant force is equal to what? How many forces are acting on the man? First is reaction force acting in the vertically upward direction. Say that reaction force is denoted by capital R, R for reaction. And mass of the man is m, and small g is the acceleration due to gravity. Then what is the weight of the man? It is mass multiplied by g, that is mg. So there are two forces, force of reaction and weight of the man itself. So which force should be larger one? One force must be larger than the other. Which one should be larger? Since the motion of the man is in the vertically upward direction with an acceleration, that means force of reaction, which is also acting in the vertically upward direction, that force must be greater than the weight of the man. And they are collinear, or better to say here, the forces are parallel to each other. Okay. So what is the net force in the upward direction? It is R minus mg. Net force acting in the vertically upward direction is equal to R minus mg, where R is force of reaction and mg is the weight of the man. So this R minus mg is equal to the net force, which was denoted by capital F. So how should we write the equation? We should write F is equal to R minus mg. And this net force F, this is producing acceleration of the man. Okay. Say acceleration is denoted by small a for apple. Acceleration is denoted by small a. Then what is the force? It is mass of the man, which was denoted by small m, multiplied by this acceleration small a. So instead of writing that capital F, we should write here now m into a. So m into a is equal to r minus mg. Okay. m into a is equal to r minus mg. This is the required equation to solve the given problem. If acceleration is mentioned in the problem, then you can find out force of reaction r, which will be equal to divide both sides by m. So in the left hand side you will get small a, which is acceleration, and in the right hand side it is r minus mg by m. If force of reaction is mentioned in the problem. And if acceleration is mentioned in the problem, then r is equal to what? It is ma plus mg. That means m into a plus g. m into a plus g, that is the force of reaction. So this was the upward movement of the lift or the man with constant acceleration. And this was the first problem. And during the downward movement with constant acceleration, there also should be two forces acting on the man, and due to that two forces there will be one net force or resultant force. So here in this case, since the movement or the motion of the man is in the downward direction, so in this case weight of the man must be greater than the reaction, force of reaction. Weight of the man must be greater than the force of reaction. So in this case, instead of writing r minus mg, you should write just the opposite, that is mg minus r. That is the resultant force acting in the downward direction. So mg minus r is equal to resultant force is equal to m into a. Okay, mg minus r is equal to m into a. So here what becomes r? Finally r becomes mg minus ma, which is equal to m into g minus a. Okay. So we can see that in the first case r was equal to m into g plus a. In the second case, during the downward movement, r becomes equal to m into g minus a. So which one is larger? For both the cases, say magnitude of acceleration remains same, and g is constant, you know that value, 9.81 meter per second square. So in the first case we can see that force of reaction is more than the second case, where the second case is downward movement. Okay. So this way, very simple problem it was. This way you can solve problems on lift. This is very common problem. Okay. This problem is equally suitable for 9, 10, 11, 12, class 9, 10, 11, 12, diploma engineering, again BTech course, first year BTech course. Okay. So you can easily solve this problem. Such simple problems, no need to write on board. I think you have understood the problem. If you find any difficulties in understanding any problems posted by me, then you can pass comments. According to your comments, I'll try to answer you. Okay. And if you like my videos, so please press the like button, as well as you may subscribe the channel to get the notifications of new videos posted by me. Okay, thank you.